Welcome to the NIAB part of the pilot system here. We've got two systems that we want to show you. First of all, I'm going to go through the ebb and flow and sort of explain what you can see here. We have the original system that we trialled in the last year, where we have rock wall blocks that sit in the gravel and the plants are sown on top of them. We're also now extending this to the new system with the floaters that were designed by the project. And as you can see, here's one of the pilot floaters, which is sitting down into the gravel, and we're ensuring that there is close proximity of the water with the roots using capillary matting that is sitting underneath the floater. We're in the process of just optimising this, so the key is that this will enable sufficient nutrient distribution and maintain the plants in sufficiently moist state so that they survive through germination into initial growth. I'll just, if I can move you across over here. We're also going to look at whether we do that straight into the gravel or whether we sit that on a second layer of capillary matting. Really, because these are originally designed to be floating on a deep water system, we're looking at moderating this to work with our ebb and flow system. And the reason that we have an ebb and flow system, as well as the deep water, is that we were told by English growers that it would be perhaps more useful to have this kind of a setup than a deep water system. So that's why we're looking at both systems under this regime. And now we're going to take you down to have a look at the deep water system and how we're using the floaters in a more traditional sense as they were designed to be used. So this is one of the ways that we're going to look at deploying these floaters. Clearly this is an ebb and flow system, and these are designed originally to float on top of a deep water system. However, I think that we have some interesting solutions to make this work. The floater will sit down deep in the gravel, so as the water ebbs and flows, it comes along underneath the floater. And we're using a very simple system to ensure that it's good contact with the roots, which is cutting the capillary matting to size. So you can see that we've got the capillary matting that's sitting inside the floater there, and that ensures that you've got good contact with the root system and ensuring that this will enable that germination, particularly in the early stages when the roots are quite small.
Hi, I'm Dominic Edwards, and I'm working alongside Lydia Smith and Alec Gazer to develop and test the pilot system here at NIAB's site over in East Anglia. Behind me you can see the constructed deep water system, infrastructure of which was supplied by Dry Hydroponics in the Netherlands to allow comparison with Vertify's system. We've split the system into 4 beds to allow us to test different varieties, different crop species, and also different nutrient regimes. In addition to the 4 beds, we've just installed overhead irrigation, and this is able to supply all 4 beds of irrigation, or we can also individually isolate individual beds to suit our needs. We'll be having LED lighting set up in the next couple of weeks, and this will allow comparison with the ebb and flow system, which we have in the other polytunnel, which was introduced by Lydia earlier. In addition, we also have air conditioning supplied by modified aircon units using air source heat pumps that allow sustainable cooling of the entire area. Over the coming months, and when the floaters arrive, we'll be filling these beds with water, allowing us to test different crop species, mainly focusing on wild rocket and salad rocket. The floaters will fill, I think we've got roughly 25 metres worth of pond space. Obviously there's going to be a few spaces in between that will allow algae to grow. So we're thinking of filling those gaps with styrofoam boards just to suppress any growth we don't want. The system behind us will be accommodating plants pre-germinated on the floaters in a cooler environment in our germination tanks.